Okay guys, this is the first video on the Regents Review videos, graphing inequalities. You want to make sure that you have a ruler ready and that you make your lines accurately. The first question says, graphing the following systems of inequalities on the set of axes shown below and label the solution set with the S. Remember that big fat S is going to be where the shadings overlap. First thing I want to recognize is that I have the inequalities here, greater than, less than, or equal to, so I definitely know I need to have some shading. So if I write these things down for myself, then hopefully I won't forget. Another thing that's important with the inequality graphs is you need to write down whether you have dotted or solid lines. Now there's no equal to under this first inequality, therefore this will be a dotted line, which means that the points on that line are not included in the solution set. The next line has an equal to under it, so therefore when we graph it, it will be a solid line. So if we look at the first line, we know in order to graph a line, it must be in y equals mx plus b form. So this equation is already solved for y. In order to graph this, I need to know what the y-intercept is and what the slope. My y-intercept is always the constant or the number without a letter, so I have b equals 2. My slope is the constant in front of the x, and in this case it is -1 over 1. Let's start with the y-intercept, which goes up to 2 on the y-axis, and to move to get to the next points, I would go down 1 to the right 1, down 1, right 1. Because remember, my slope is rise over run. Then you want to take your ruler, and remembering that this is a dotted line, make sure that you line your ruler up with your dots, and you want to go through it, making a dot or a hash mark every so often. You want to make sure that your line is as big as your graph paper. Put arrows on the end, and since this is an inequality, we want to make sure that we shade. We always want to test the point 0, 0, unless, of course, your line goes through that point. So when I test 0, 0, I always want to test it in the original inequality that's given in the problem. So I have 0 is greater than -0 plus 2. Therefore, 0 is greater than, -0 doesn't mean anything other than 0, so then we have 0 is greater than 2. This is a false statement, so therefore I shade where 0, 0 is not. I'm going to shade on the other side like this. Next, I want to shade or graph the second line. The second inequality is y is less than or equal to 2/3 x plus 5. This is nice because it's already in y equals mx plus b form. I don't have to get y alone. All I have to do is write down my slope, which is always the constant in front of my x, 2 over 3. My y-intercept is 5 in this case. So now I'm going to start at 5 on the y-axis. 1, 2, 3, 4, 5, my first point. To move to my next points, I'm going to go up 2, to the right 3, and let's do it again, up 2, to the right 3. We want to have at least 3 points to graph our line. Take your ruler. Now in this case we have an equal to underneath the inequality, so again we want to pay attention to the fact that this will be a solid line. Graph that line, put arrows on the end, again making sure your line is as big as your graph. Now we want to decide what side of our line we're going to shade on. Again, let's use the point 0, 0. Substitute that in your original inequality. 0 is less than or equal to 2/3 times 0 plus 5. Anything times 0 is 0. So we have 0 is less than or equal to 5. This is a true statement, so we are going to shade on top of 0, 0 because it's true. You want to make sure you also shade the graph all the way on that side of the line so that you don't leave any portion of that area unshaded. Now the last part of the problem is to label the solution set. Remember our big fat S, we want to put that S where the shadings overlap, which is in this area right here. So we're going to put this big fat S right there. Okay, now I want you to try the next one, and you'll see in the next video the answers to the next 2 inequality problems. Good luck.